I'm sorry, were you speaking to me?
Yeah. Hi, how are you? How are you?
Hi, I'm good. Thank you for having me.
Oh, anytime, man. So I think, guys, let's begin. We are expecting a few more people, but I think they'll join us. In the, yeah, in the respect of time, let's just start. So thank you everyone for coming on. My name is Puneet Mehta, for the guys who don't know me. So we are a part of Bombay Watch Enthusiasts. And today we have this wonderful session by Mr. Sarosh Mody from Luxury Watch Works. So first I'll give you a quick brief about Bombay Watch Enthusiasts. We are a group of watch enthusiasts mainly from the city of Bombay, but actually from everywhere. And our main point is to build a strong community of watch enthusiasts, mainly from the city of Bombay, so we can actually meet each other and obviously discuss watches, share knowledge, share insights, and have a lot of fun. Firstly, please just mute. Yeah, perfect. Cool. So I was talking about Bombay Watch Enthusiasts. Yes. So we are a group of watch enthusiasts, like I said, and currently uh, during the COVID season per se, we have made it more formalize it even more with the social media handles, etc. Before that, we used to meet very often, but obviously after COVID, that's not possible. So we came onto the social media, and now we are trying to do some virtual events like this one. So this event or this webinar is called Risk Talks with BWE. This is the second episode. Before this, we had one with Visha Watch, and now we have one with Mr. Sarosh Mody from Luxury Watch Works. Not taking too much time. A lot of people out here already know Sarosh from the watch industry. He is one of the ace watch experts in the industry who has his own service center, and right now they're tied up with 21 brands per se, and they are located in Bombay, in Prabhadevi in Bombay. So I would highly recommend Sarosh in case you have a good watch and you want to get it serviced. So handing it over to Sarosh. Sarosh, hi, are you there?
Yes, I am. Hi, Puneet. Thank you for your generous introduction. Good evening, everybody. Thank you for taking the time to be with us, to be with Bombay Watch Enthusiasts for this evening. When Puneet and myself sort of started talking about doing something together, we just wanted to explore it from an absolute rudimentary concept. So we're just going to have I'm just going to take a very, very quick run through through the history of horology, and then sort of come to the aspects of sort of shedding some light over the kind of complications that are present in modern and contemporary watchmaking today. So are we ready to start, Puneet?
Yes, absolutely. I think by all means.
All right. So I'm just gonna share screen.
So just few, like while Sarosh puts it up, just few ground rules. So basically the format of this webinar meeting is that Sarosh is going to be giving us a short presentation on the anatomy of timekeeping, which will involve topics, like he said, from history towards the complications, etc. And when he's presenting, etc., we'll keep our questions on the chat. In case anyone has these questions, please put it up on the chat to me or on the group chat, and I can just direct them all to Sarosh whenever he gives us the chance to do that. And yep, I think the presentation is live. Yes.
All right. So Puneet, is it live on the screen?
Yes, you're live.
So I'm just going to take you through this. So in essence, if we are looking at the era of time measurement, essentially, and not just watchmaking, it's been an evolution of over 3,000 years. Human understood that, you know, I can just put a stick in the ground, and the shadow of the sun falling can sort of give me a time sequence to what hour of the day is passing by, and that's how the whole advent of timekeeping started taking place. The Babylonians and in ancient times, who were one of the people where they divided the calculating year at that particular point of time into 360 days by observing the sun and the seasons. And I think that's how they sort of came to the invention of an hour. Of course, over the advancement of science and the evolution of mankind, we now have 365 days to be sure. So the Greek history and the scriptures sort of depict the advent of the sundials to the Babylonians, but we necessarily can't sort of be sure that it came from a single place point of origin. The picture that you see on your screen is known as the Cleopatra's Needle, which was originally in Egypt. It is a larger version of a sundial. And today it stands on the embankment of the Thames River in London. Another popular example is the obelisk that you see in Place Vendôme in Paris, which was also used as a sundial. This is one of the earlier examples that you see where this particular rod would sort of cast a shadow through the sun over the hours, and that's how we sort of got the rudimentary hours of the day passing by. And then, of course, it got integrated into architecture also. So here also is an ancient example of a sundial that you see. Then, of course, the advent of the sand clocks, and I don't address them as an hourglass, which we normally do in today's time, is because of the fact that there were many sand glasses which could even go to 15 minutes to half an hour to 1 hour, depending upon what their construction was. This is an ancient example of a candle or a flame clock which would cast a shadow, and as the flame would sort of burn through, you would see it on the hour markers over here. Of course, the picture is really very old and I couldn't sharpen it more, but that's how they used to read time at that particular point. The clockwork or the gearing started coming around during the Persian era, roughly around anywhere between the 13th century, dated between 1221 to 1222. And these are the most earliest examples that have been found, which was basically on an astrolabe. An astrolabe was used by the astronomers to basically know the position of the planets and the stars in the sky, even the constellations. And then, of course, as the time advanced, you could see the advent of astronomical clocks, mainly in cathedrals, churches, etc., all over Europe mainly. This is one of the famous Strasbourg cathedral clocks, which is inside the cathedral. And of course, as technology grew in that particular point of time during the medieval ages, it got more personalized, and this is one of the first examples of a timepiece that you could sort of wear on yourself. I wouldn't call it exactly a pocket watch, because the dimensions were still way more bigger than the modern pocket watches, but this is one of the earlier examples. All you can see is just one hour hand to indicate the hours of the day over here. As and how time passed, a lot of navigation used to take place by sea, and before the advent of the longitude, timekeeping was how they would take the record time at the port of departure, and they used to calculate as per time. So the navigation and timekeeping were very, very integral. And this is one of the most important timepieces in history. It's called the H4. It was done by a carpenter called George Harrison, who won the British Longitude Prize for one of the most precision timekeepers at that particular point of time. Harrison, of course, did 5 examples, namely H1, H2, H3, H4, and H5. and the H4 landed up winning the prize, as I mentioned. So in terms of the pursuit of chronometry or precision timekeeping, this was one of the most historical steps that we see in the last few centuries. And then, of course, the advent of the pocket watches started coming in, and I found this particular example very, very interesting because it deviated from a single axis hour and minute timekeeper to sort of a retrograde, which we usually even find in modern pocket watches. So here you have an example of a gentleman standing, pointing between the hours. These would be the hours over here, and these would be the minutes. So the moment you would have an hour complete, you would have the 60 minutes in completion, his hand would again sort of jump back to 0, and this would advance a particular hour over here. And as we spoke of marine chronometry, this is one of the examples I found on marine chronometers over here, just to show you. Of course, in modern day, we see a lot many watchmakers now coming with the cylindrical hairspring over here, but over here you see, because of the mainspring torque over here, the high mainspring torque, look how thick the hairspring of this particular chronometer is. And of course, the last and final in my history bit, which I sort of gathered to you because we have a limited amount of time, so I've picked bits and pieces which I found most interesting through the history of timekeeping for the past 3,000 years. And electrical horology was something that sort of comes as close to as the contemporary times of what we understand of watchmaking in the modern era. And over here, instead of having a regulator which would be mechanical, the power source is replaced over here. Instead of a mainspring, you have electricity being used, and that's how the advent of you could say like this was a stepping stone towards the advent of quartz, that is the battery operated watches being used maybe roughly around 50 to 60 years down the line, after the invention of after the introduction of electricity into timekeeping. Okay, so that's what I wanted to share from here. And okay.
So Sarosh, quick question from Karishma, that the picture with the hands, you know, the movement.
The retrograde display?
Yes. So what brand would it be? Do we know that?
It's an unnamed timepiece. These are all from the museum archives, and if the museum doesn't have the name, I don't know where there's a person like me who can even find out to who's the maker. But I think if you, I'll just share a small tip with you. By the 1800s, okay, Britain was making half of the world's watches, around 200,000 watches a year. Of what we know of the predominant Swiss that are sort of ruling the roost since the past 100 years, it was a very, very different story. So I think if we are looking to see the origins of this particular watch, it could be a British watchmaker who could have done this one, possibly.
Right. Cool.
So, sorry, 1 second. Okay. So, okay.
Sorry, another quick question.
Yeah.
Do you think if electricity is being used to generate energy, can digital watches use a similar technology and become a hybrid? Is it possible technically?
There are actually, I mean, you want to use battery as a source or electricity as a source?
Vritti, go on with your question. I mean, go unmute yourself, school.
Can you hear me, guys?
Yeah.
Yes.
So electricity as a source, like how we are already charging our digital watches, right? So do you think there could be a possibility of merging like electricity and have
Have
a
what?
mechanical system inside? Like maybe even in phones, is that possible?
See, let me just introduce you to this. Brands like Seiko and Citizen have been doing it for the last couple of years, where essentially you would have an analog watch, that is the one with the hands, and it would have an automatic rotor, just like a automatic watch. And instead of having a mainspring, it would have a sort of small generator and an accumulator inside. That what it would do is, once the free moving mass get moving due to the impulse of your wrist, it would generate this little voltage and keep storing into the accumulator, which would then power your watch. So
Okay.
the technology like this, of course, exists. The same kind of technology you would also have with solar dials, which could again keep charging your watch. Citizen does a lot of them. The clocks which you see at railway stations, for example, okay, they are electrically powered. You know?
Yeah.
So you still have a lot of, as you say, like a hybrid, where you have mechanical components together with electronic components, which could either sort of run on a battery or a small accumulator or via electricity. So it still goes on in today's date.
Okay. So another quick question, Sarosh. Do you think a similar technology, like how digital watches, some are not being successful these days? One of the reasons is because they lose their power very quickly, right?
Mm-hmm.
So, like how you said, is that a possibility that you can actually generate power through either hand movement or solar
Yeah,
energy
it
in
already
a digital watch?
it already exists. So say, for example, if they were to add a rotor system with this tiny small voltage generator with an accumulator, this already exists with Japanese technology.
Okay.
Yeah.
Okay. All right. Thanks.
You're welcome. You're welcome. So shall we proceed, or do we have any more questions?
No, I think we can proceed.
All right. Okay, so we're just going to run the absolute basics of mechanical watchmaking. Like in a toy, when we were really young, and we used to sort of wind the toy, and then it would sort of ring the two symbols together. You always had a spring inside, and the moment you left the key, the gear rotation inside would start and transmit that energy from the mainspring through the gear train to the impulse. So the same way, it's a very simple concept over here. So you have your winding mechanism, okay, which goes to the motor organ or the mainspring in this manner, transmitted through the gear train, all right, reaches the escapement system, and of course then to the balance wheel, and that's how your timekeeping takes place. And of course, if you normally pull the crown out through the watch, which is onto the side of your watch over here, you can always set your time. So this is something secondary over there, which I would take you through again. So normally when you look at the movement, it has two faces, just like a two face of a coin. So here what we see is the gear side, and then you have the winding side. This is where usually your dial of the watch sits, and then you have the hands, and then you have the crystal in a watch. So as we said, you always have the mainspring, which is your power source over here. Okay. When you wind the watch, the transmission of energy takes place through the crown wheel over here to the ratchet. Of course, we don't want to get very, very technical, but it's just for you to understand the basic mechanism of operations over here. This particular spring and click is what sort of keeps the mainspring from unwinding itself as quick as possible. And through this gear transmission train over here, you reach the regulating side or the regulating organs. So mainly 1 second. Puneet, am I still audible? Hello?
Yeah,
Yes.
you're audible.
All right, sorry, because I thought it showed me a mute over here. So these three components are extremely important in a watch. Here you have your escape wheel, which is this barb-toothed wheel. You have your lever, and then of course you have the balance wheel, which also, if you need an example, it's like the pendulum of your clock. So when the balance wheel goes from left to right, you can just sort of imagine your pendulum going from left to right. It's the similar action of how a wrist timepiece would sort of work. And this is a little focus on the winding side. So this is basically your key, which is attached to the crown over here, the winding stem. And of course, it's a dual system over here, because you wind your watch and you build up your power reserve. And when you pull this particular winding stem out through the action of these particular set of springs, you can disengage from building up your power reserve to actually setting your hands. So this is the basic principle on how mechanical watches work. Let's come to the aspect of discovering different kinds of complications that are there. Yes.
Quick question. Why do we, like someone just asked me, why do we have jewels in a watch? Can you explain the technical side of the movement?
Yes, it's a very simple answer to that. So say, for example, this is my main plate. This is the pivot of my gear. It has to sit, right? It sits between two parallel plates this way. All right. So say, for example, if the metal is going to be in friction with another metal, it's going to wear itself out. Okay. So to avoid that, they started using the jewels, as you know, are actually synthetic rubies. Okay. Which a watchmaker, while assembling it, will put a little drop of lubrication in between the jewel and the pivot. So a fine drop of lubrication will be put over there. So the natural ruby provides the synthetic ruby provides an extremely smooth surface together with the specific oil for the pivot to rotate freely within the movement. Right?
Makes sense.
Yeah.
Thank you.
Any questions?
Not on the group right now.
All right. So, usually a complication is, as defined by the Swiss, comes in with the advent of date. So anything above an hour, minute, and a second, whatever other display that you see on the dial side or on the movement side, additional to that becomes a complication according to them. But I think having an hour, minute, and a date watch is it's quite simplistic, so we don't want to count it in a complication. So the most known complication amongst watches is always a chronograph. So let me just clear this point out before we start. There is a difference in terminology between a chronograph and a chronometer. So there are two different things. A chronograph is an additional time measurement apparatus which is there within your watch, and a chronometer is usually a certified watch for its precision timekeeping. So they're two different things altogether. Okay, so with chronographs, normally you always have these the subdials over here. So one would be for your regular seconds. Okay, one would be for your minutes passing as you sort of activate the chronograph through a push piece over here. So this would normally read you the seconds. This would normally read you the minutes that are passing by, and this would read the number of hours that are sort of passing by. Okay, so why, like say for example, in sports or in races, they used to have they used to measure time because that's how competition is measured. And in chronographs mainly, I noticed 3 kinds of dial gradations. So you would always have a tachymeter. There's a tachymeter, there is a telemeter, and there's a pulsometer. So I'll quickly run through these 3 different terminologies with you. So a tachymeter usually is used normally when you need to do rapid speed calculations. So say, for example, you start from your start point with a car. The moment you cross 1 kilometer, you deactivate from your start and stop over here in the chronograph pusher. And the reading over here will give you the speed of that particular car, which just crossed by. With a telemeter, it was mainly used to measure distances. Okay, the same sequence. You start your chronograph, and when you cover that particular when you reach your destination, you press stop, and it will show you the distance that has been done. And of course, pulsometer, it was used mainly by medical professional. So the moment you start sort of taking the pulse, you activate the chronograph, and after your basic count to what you want to record, you just switch off your chronograph, and it will tell you how many pulses per minute that it went up to. So usually we see chronographs with a pusher at the 2 o'clock position, and normally a pusher at between 4 and 5 o'clock position. So the upper one is to start and stop. The lower one is to reset your chronograph. But these are mono pusher chronographs, meaning that you would start, stop, and reset the chronograph through this one single pusher, as you can see. So technically a more complex movement to make and manufacture. And you have very, very few companies still making mono pusher chronographs. Flybacks. The flybacks are normally there for rapid reset of your chronograph watches. So as you would sort of normally activate from the pusher at your 2 o'clock position, if you needed to take a time interval, so for example, you complete 1 lap and you want to measure the other lap independently, then you could just go to the 4 o'clock pusher, press it once, so that even while your chronograph is in motion, the seconds hand would jump back immediately to 0 and keep going. So you wouldn't waste precious seconds in between to sort of start, stop, reset, and start again. You know what I mean? Any questions on that?
Guys, any questions till now? Yes, we have one from Karan. Can one incorporate flyback the flyback function in a mono pusher chronograph, or is it always a slave to multiple pushers?
So the ideology behind mono pushers was that you get the convenience and the aesthetical appeal of not having too many pushers around. But if you needed to incorporate a flyback function, you would definitely need an extra pusher. So probably you could have the mono pusher working through your crown itself, but then probably at 10 o'clock or 8 o'clock, you would have to have an additional pusher to activate the flyback. Otherwise, there's no way of sort of bringing about that interval in that.
Okay, how complex from design point of view is a flyback in comparison to a standard chronograph movement?
It is complex. It is complex. It requires another set of gearing and springs, which is incorporated within the movement to do this.
Right. Anything else, guys?
Okay, so this is another example of a flyback over here that you see. And of course, we've all heard of the French terminology, the rattrapante, or the split-second chronograph. So the split-second is a little different from the flyback. So normally you would have both the hands at a 0 position when you are at a stopped chronograph mode. Once you start the chronograph, Okay, so in this case, Puneet, here it answers our question which was there. So can you have a flyback or a Ratrapant through a mono pusher only, which is not a possibility. So you see your start, stop and reset is through the mono pusher over here. But for your additional functionality, either a flyback or a Ratrapant has to be controlled by an additional pusher. That's how we see it. So if you were at 0 right now and you activated your chronograph, both the hands would move together around the dial. Now the moment, so say two people are racing in their car, okay, and you're keeping time, and gentleman 1 crosses the finish line, okay. At that particular point of time, you do not go into stop over here, but you activate this particular pusher, hence activating the flyback, the split second function, where this particular hand will keep proceeding till you want to stop it from here. So you've recorded Mr. A passing the finishing line at this and Mr. B passing the finishing line at this. And that's how a split second chronograph would help you keep 2 time intervals independently. And then of course, the moment you press this pusher again, it will go in sync, and then you can just reset the chrono and it'll go back to 0.
I think Ahan has a question which says what was the need for the function for this for the Ratrapan function, but I think you just explained that.
Yeah, so I guess. Do you want me to explain it again?
No, I think it's good. You just
right.
said the same thing, yeah.
Okay, so regattas. Regattas are normally regatta is normally a sailing race. So you would have yachts or boats compete for it. And usually when you are docked to the time you reach the start line, there is a certain interval that you sort of have, which the boats to pick up speed are given a 10-minute interval. So while you are using this particular chronograph function, okay, this is basically, instead of chronograph measures from 0 to up, the regatta would help you do a countdown. So you can bring it to a 10-minute countdown, okay, and then you can start your countdown. So it'll count in reverse. So it'll be like 10 minutes, 10:50, 9:59, 9:58, and so forth till you reach 0. So 0 is your starting line. So your boat should be in absolute momentum to compete in the race by the time it sort of gets out there. So that's the basic function of a regatta. Again, quite a complex movement. Very few watchmakers in contemporary times do regatta chronographs, countdown chronographs. And of course, this is one of my favorites because in the last 100 years, we've always seen chronographs which are divided into several axes. Axes meaning you would have your seconds hand in the center, then you would have the subdial at the right hand side, either telling you minutes, subdial on the left telling you hours. Over here, this particular movement and technology was developed by Jean-Marc Wiederit. He owns a company called Agenhor, and hence you have the name Agengraph. So the basic principle is, what he's done is he's combined all the subdials together with the central seconds onto one axis, where your chronograph is this particular one. Don't confuse it with the timekeeping. So your hours and minutes are over here. Your hours and minutes of your regular your timekeeping are over here. But the chronograph sequence in terms of hours, minutes, and seconds is all on a singular central axis. So in terms of technological development, I think this came about roughly around 2 years ago, if I'm not mistaken. And this particular gentleman has been extremely innovative into presenting something very new in terms of a mechanical principle in sort of development and execution of chronographs. Another example, again, this movement is also done by Agengraph, but in the earlier picture, Fabergé took it for their brand. And in this particular example, Singer is one of the other watchmakers which does racing inspired watches. So they've taken this particular movement to use in their watches. Any questions for that? Okay, so we'll proceed with the calendar aspect of things. So normally there are 3 to 4 types of calendars. With
Sorry, Sarosh, I'll just butt in here. There was a question about Lange. So the triple split. So Ankur has a question that the triple split is only made by Lange, or does anyone know if any other company makes the triple split?
Honestly, I have not heard about anyone else making a triple split, but I think all of us are quite inclined towards reading and knowing about watches. So if anyone has an opinion, please do share right now. Anyone? No?
And one more question was from our Indian customers client mindset. Vitti had it. Do their opinion, in your opinion, do the Indian customer understand such complications? Just from a feedback that you've been dealing with a lot of guys who own a lot of good watches. So do they really understand these complications, or they are just bought for the whole wow factor?
See, a lot many consumers have lot many different things when they look at watches. Okay, so essentially, I think more than 70% of people at least in our country, I'll just speak from an Indian perspective. More than 70% are only skewed towards a name. So hence you always find people, of course, through various categories, but they would always be chasing, oh, humko Rolex hi chahiye, humko AP hi chahiye, humko Patek hi chahiye. But if that's the client, then they are basically just going behind the name. They are least bit interested in what the watchmakers have to offer in terms of innovation or the finish of the movements or the aesthetic of the piece. They're basically just chasing a name. And then, of course, you have a lot many informed individuals, enthusiasts, collectors who approach watchmaking from a very, very different aspect. So I have met a lot of people across who say that, listen, I'm not going to waste my time on Rolex, because I mean, if I'm sort of out there to spend money, okay, I don't want to wear a watch which is seen on several other hands. And another extremely important point that he shared with me is the counterfeiting aspect of things. Because nowadays you have such good counterfeits, coming from the Southeast Asian part of the world, where you have grades. So you would have a poor replica, and then you would have the grade A, grade B, and grade C, So sometimes people land up paying top money because you just want the name, but at the end of the day, you're just fooling yourself and no one else, So the people who are well informed and into watchmaking, there's a whole new world of things out there apart from the Pateks and APs and Rolexes of the world. And I mean, of course, we might see a glimpse of them because they are exceptional brands. They do exceptional quality work. But as I said, it's a world of watches out there beyond just this.
Right. So a couple of questions quickly. Are there any benefits to the Ratrapante as compared to the flyback mechanism? I think you covered that, but maybe if you want to take it.
No, it's you see. Please understand the era from where these developments come from. Okay, there was no digitization. These were actually instruments. Okay, they were work tools for some people. Okay, like for example, a diver's watch. Today, to me, a diver's watch is absolutely redundant because you get much better electronic equipment to measure your depth and your oxygen levels and everything else to the T, and they don't face a failure. You don't have a fear of failure over there. Some things can be they're connected to absolute satellite navigation and things like that. So technology today is very, very different. We are well more equipped in the current era, but to the era when these innovations came in, you didn't have a choice. These were your only time measurement tools, as to say. Today, we look at it from another aspect of things because it's heritage, it's craftsmanship, it's the brand, it's a history. You own a piece of history, not for the usage as per se, but for it's fun to have something where you feel connected to how it was done a couple of 100 years ago, and you own a piece of that heritage. So I think it's if you see the usage between the two, it's quite similar. But then again, if you need to make a choice whether you need a regatta, you need a flyback, or you need a split second, it's up to you to how you land up using it. But I think 90% of the people out there who own chronograph watches sometimes just leave it open for the fun of it because they don't know what it's supposed to do, or sometimes don't land up using it. So it's just a damn good looking complication at the end of the day.
We'll take one more very, I think it's an interesting question, that does using the chronograph affect the timekeeping or the accuracy of the watch, or you should use the chronograph if you have one in your watch in order to keep the engine running after some time? So
no, so it's a very, very good question. You see, the way the movement is constructed, okay, is in the start of when we started the presentation on the basic of the movement, did you see the balance wheel? Okay, so the balance wheel going to and fro is called the amplitude. Okay, so the way a mechanical watch is made is that they keep in mind and calculate and manufacture it and engineer it in such a way that the healthy amplitude always remains, but you will always see a fluctuation in the amplitude of the balance when the chronograph starts, because it's an additional function which is again drawing additional energy from the mainspring. So the torque is a little bit divided. But that being said, the engineering is done in such a way that the amplitude does not drop down to a drastic level which can affect the usage of your watch and sort of lower the accuracy of your timekeeping. So that's the way they are engineered. But yes, there is a drop in amplitude, technically speaking, but it is taken into calculation that yes, the chronograph is meant for use. So whenever you feel like using it, please use it. So it shouldn't be a problem. The only thing I would say is if you are in frequent usage of your chronograph, even if you're wearing an automatic chronograph, try and wind the watch roughly around 20-30 times so that the mainspring is fully wound and your torque is sufficient enough not to let the accuracy be affected.
Right.
I'm sorry if I've rambled on. Please, you can interrupt me and ask me the question again. Okay?
No worries. But then also it's a bad idea to kind of just keep it on, right?
It's just going to increase the wear because these were not functions which were meant to be on 24/7, 365 days of the year. They were supposed to measure time intervals, and that's how the engineering has been done. So I would suggest that you don't keep your chronograph on 24/7, 365, just to sort of ensure lesser wear and tear of your watch.
Right. So we have Aditya Samare here who...
Oh yes, I know Aditya, Pune based, lovely technician. Welcome Aditya.
So he has a very interesting point that the exception is the Seiko 6138, 6139 family. In these, the chrono should always be kept running. I think, Aditya, can you come online, unmute yourself and maybe just explain to us this point?
Yeah, hi Sarosh.
Hi Aditya.
Sorry to butt in like this.
Not at all. Pleasure to have you here.
No, the thing is that these have a vertical clutch, it's not your traditional sliding mechanism.
Yes.
That the center wheel and
which movement are we talking?
The Seiko 6138 and 6139.
Okay.
So there, the seconds wheel and the chronograph wheel and the fourth wheel, they're all stacked together.
Yes.
Now, and those are out of production. Seiko doesn't support those vintage parts.
Okay.
If you keep the chrono in the off position, you're stressing the spring.
Okay.
And if you engage the chrono, the spring is released.
Okay.
So in the interest of less wear and tear, and because it's an irreplaceable part, these chronos should always be kept running. And they don't cause a drag like your traditional chronograph mechanism.
So that's a good point that you shared with possibly, I'm sure this particular information is extremely useful for the Seiko owners in this forum. And maybe outside. That particular information was also quite valuable to me. But then it also brings me to a question that if at all they felt that this particular technology, the way they had devised it a couple of years back, and if they thought that this was really sure shot and it was good and it could continue, they would have kept it in production even in today's date. Don't you think so?
I'm not sure what Seiko uses right now. I don't know if they still use this vertical clutch. Plus, we are talking about 1960s and 70s metallurgy.
Yes. So that also gives us a little bit of an indication, saying that as and how technology is moving, metallurgy improves, the CAD improves, the engineering improves, the performance aspect of movements, the way they are designed, engineered, and manufactured improve. So again, then probably these kind of things become a little bit more redundant. You know what I mean?
Right.
So to a vintage enthusiast, your suggestion that you gave in right now, they are pearls of wisdom. But from a modern aspect right now, if you look at the chronographs that we are using right now, okay, I wouldn't suggest someone to sort of just leave it open 24/7. Right. So shall we continue?
Yes.
Thanks, Aditya. I'd love to chat up more with you.
Sure. We should connect. We should connect.
All right, cool. Thanks. Okay, so what we see on the screen over here is a complete calendar. Of course, the name describes it all. You have the days of the week, the months of the year, and of course, through this particular hand, it indicates the dates, the date function over here through this chapter ring. Now, this kind of calendar has to be manually adjusted every alternate of the month. So say, for example, we were at July 31st, but in August, we are going to have 30 days. So you might, for 1st of September, you might just have to go a complete day around to bring the hand to 1. It does not take into account the alternates of the month, so to speak. Whereas over here with the annual calendar, what it does is it automatically, the mechanical movement will indicate the alternates of the month. So it would indicate you 30th of June and then the 1st of July. And then of course the 31st of July and 1st of August, and in that consecutive sequence. So what it does, the annual calendars normally what they do is that they take into account the alternates of the month and hence annual. Going a step ahead, okay, these are another few examples of annual calendars that you see. Again, very, very different from the way Lange has done it. Rolex has done it extremely different. IWC has done it extremely different. But then again, the same principle applies. They are all annual calendars over here. Perpetual calendars. Now, perpetual calendar would mean that it would take into account the date change of from the 30 to the 31st automatically. And then so it would continue like this for 3 years. And on the 4th year, from 28th of February, it would show you the 29th, signifying the leap year. So a little focus towards this particular subdial that you see. So you have your months of the year on the outer ring. And then in between, you have 1, 2, 3, and 4. So it'll indicate that these are 1, 2, and 3 years where you have February as 28 days. And the 4th year, which is the leap year, you will have February as 29th. This is pre-programmed into the mechanical movement via the gearing system and the snail cams. And it will automatically indicate this particular sequence to you if your watch is in perpetual motion. That means if you keep it running, yes. If you don't keep it running, your calendar is going to stop. You might have to rewind the watch and reset it. The higher the complication, sometimes the more it is a hassle for somebody who wants to change the time or the date on their own. Sometimes We find a lot of watches coming to the service center where the perpetual calendar has stopped and the owner has sort of gone way ahead in calendar settings. So we have to open the watch and reset the whole calendar for them. A quick tip for all you people owning date watches to complete calendars to annual to perpetual, never go behind time. And if at all you have to adjust, you never adjust any date function between 8 p.m. to 3 a.m. That's the time when the whole cyclic gearing comes into play and the watch is getting ready for a gradual date change. So what you do is you put unnecessary tension between the gears, which can sometimes land up damaging your watch from the inside. So it's just a tip, never ever set your date between 8 p.m. and 3 a.m. Any question on calendar watches?
I think a very interesting point which you brought out here is that which is there all over the internet in terms of a lot of blogs also, that people are facing it very difficult to kind of but set their perpetual calendars, because if you are an enthusiast or a collector, you might be having more than one watch, and in rotation this doesn't come in. And then again, you have to sit and do the whole thing. Some people consider it as like as a ritual, and like as this holy thing which they sit and do it with their watch. And some people are just fried, and they actually, I know people who have actually given up their perpetual calendars also because they have not.
Okay, why didn't you tell me earlier? I would have taken it off their hands. Yeah, but I mean that. Not every complication is as complicated to even set. So what I really like, and especially I'm bringing your attention to this particular watch over here by H. Moser and C. It looks like a simple date time watch, but if you look closely, there is this little arrow which is below the hour and the minute hand. So what you are looking over here is actually a perpetual calendar. So the date is over here. This particular one points to the month that we are in. So basically January, February, March, April, May, June, July, August, September, October, November, December is how the months are read through this particular pointer. All right. And to the behind, okay, 1 second, I need to move this. So yeah. To the behind that we see on the back of the movement, okay, the black portions are the ones that indicator, it's an indicator for the leap year over here. We got that? Yeah. So of course you don't have the days of the week, but it's an ingenious system devised by them. This has been with this watch was presented by the brand roughly around 4 to 5 years ago, maybe even more. And in this particular system, the way they have devised the gearing in this particular system, the date can be taken back or forward, okay, which is never usually the case with perpetual calendars. So it's an extremely articulate piece of engineering, micro engineering that you see over here. And I don't think anybody else does this kind of a perpetual calendar over here. Oops. Okay. So another sequence of complication is world times. Also, so either you can have just one singular hand apart from your timekeeping between hours and minutes. You could have another one. Normally those are called GMT watches, which of course you can set it to any other time zone also. But then if you are looking at simultaneous multiple cities across, then the world time is an extremely handy complication. Various representations, various designs. So you could have something sporty to an absolute classic elegance over here. Again, all world time functions. The next complication that we are addressing is something called retrograde. Now, retrograde is a different way of reading the time on the dial. So what it usually means is that if you see the gradation over here is from 0 to 60. This is for the minutes. And so this is your minute hand over here. And you have the hours over here in a digital format where the discs would jump to change the hours. So right now the watch is showing roughly around 12:45. As soon as it completes 60, this hand would instantaneously jump to 0 and the hours would go to 1. That's how a retrograde usually works. So there's a lot of correlation between retrograde watches and even jumping hours. So the jumping hour sequence, if somebody says that, oh, I need a jumping hour watch, what is the jumping hour calculation or complication? What you see over here is when the hours are instantaneously jumping to another one, that is your jumping hour sequence over here. So you have various representations. This one is over here is done by Van Cleef, this one by UBC Nada. This again, this is done by Urvek, where you have a linear retrograde going on over here. So you have your minutes up and the hours below. And this, of course, is again a different kind of a retrograde reading where you don't have an instantaneous jump function, but the smaller hand would normally read your hours from 8 hours to 1800 hours, and then gradually this particular long hand would take over the rest of the hour reading. So quite an ingenious system. Again, this watch is done by Sven Anderson. Here you have a few examples of jumping hours. So as I said, quite a lot of correlation between the retrograde minutes and the jumping hours. But then of course, you also have jumping hours and jumping minutes, something what IWC did to recreate one of their historical pocket watch pieces called the Paul Weber. And of course, I remember there was one question that we addressed, that when the chronograph is in use, will it affect the accuracy or the power consumption of my watch? And that's how we had addressed it. So a lot many watchmakers have devised a way of maintaining a constant torque. Torque is the force that the mainspring exerts to transmit the power from the mainspring to the gear train and then to your escapement system. So usually what happens is, as the mainspring starts losing power, as it starts unwinding, towards the end, sometimes the power is not that efficient to keep accurate timekeeping. So while your reserve is on the absolute last few minutes, like your 30 minutes, 40 minutes last of power reserve left, there could be a variation in timekeeping. So probably the watch goes a little off. It's not extreme, but it just goes a little off. So there was this constant challenge to the watchmaking community, where they wanted something that till the last drop of reserve left in the watch, we should have accurate timekeeping. And that was the innovative force behind force constant. So the name force constant says that it's going to give you the exact force from the mainspring, which is absolutely full, to the mainspring, which is absolutely going to die. It will keep the constant force towards the escapement system. So you have various kinds of force constant systems which have been devised. Here you see something by FP Jaune, who was the first watchmaker to integrate a force constant mechanism to a tourbillon movement. So he calls it the remontoire. It's through a remontoire spring. I'm not going to get into the details because we are eventually now running out of time and it's extremely technical. Here you see a very old technology where you have a chain and you have a fusee. The advantage was that as the chain starts wrapping around the fusee, when it's unwinding itself, okay, till it reaches the last one, you can maintain the absolute constant force. And of course, this was done by Gerard Perregaux. Again, an extremely complicated system, but I just wanted to share with you what it looks like. So you have now 3 different kinds of force constant as at least a viewpoint to understand what force constant is all about. And then, of course, the most spoken about complication in contemporary times is the tourbillon. So, do you remember when we first saw the diagram of the mechanical watch? We saw the escape wheel, an anchor-shaped lever, and a balance wheel, which was there. So, to sort of really summarize to what a tourbillon is, it is the balance wheel, okay, the escape wheel, and the pallet fork, which are into a rotating cage. Now, this particular system was devised by Abraham Louis Breguet in roughly around 1801, and he patented it at that particular point of time. The system did not originate for wristwatches. Let me tell you that. The system originated for pocket watches, because pocket watches, normally you have the key at the 12 o'clock position, and then you have your usual chain. So a gentleman or a lady using a pocket watch would always keep it key up, and that's how the watches were regulated. So the Breguet's invention was this way, that when my pocket watch is mainly stationary in this vertical position, okay, I want to keep the main regulating timekeeping organs, okay, in a rotating cage, because the action of the gravity, okay, is going to be different in 5 different positions. So in different position, the accuracy of the watch is going to be affected by the gravity. So in normal watchmaking terms, when we test watches, it's usually the dial up, the crown up, crown down, dial down, and again crown up. So that's how we normally check. And if the pocket watch is going to be stationary in this position for longer periods of time, only accessed when the person wants to sort of see the time. So what he did was, the balance that he put over there in a revolving cage, he wanted to minimize the action of gravity in one position. So if the regulating organs are going to go around once a minute, okay, in the revolving cage, thereby the gravity is not acting on those components or the balance spring in one stationary position, thereby nullifying the inaccuracies caused by gravity. So that was the basic principle behind tourbillon. So when we see tourbillons in watches, I have mixed feelings about it, but that's something for another topic, another day. But this is what basically a tourbillon does. And then, of course, if I've put these two together so that you can understand. If a regular tourbillon normally has a bridge which holds the tourbillon over here, but a flying tourbillon doesn't get held by a bridge. It is held down by another system below the tourbillon, which gives it the power and the impulse. And then, of course, you have various innovations also in tourbillons. So while the tourbillon rotates within the cage, there are also certain tourbillons which would, while revolving in a cage, also go around the complete periphery of the dial. So then hence they got to be known as orbital tourbillons. This is a biaxial tourbillon over there done by Jaeger-LeCoultre, which they call a spherotourbillon. So while the tourbillon is going in a 360-degree rotation over here, this particular piece below, it angles the tourbillon to even function in another rotational system. So so while it is rotating this way, it is also going this way over here, and hence instead of a regular tourbillon being in one stationary axis, it's giving you a double axis over here. So I don't know, it's not very visually appealing to you to sort of see the gestures on my hand, but that's the best I can sort of explain over a virtual medium. And of course, the gyro tourbillon, what it does is, instead of being biaxial, it rotates on 4 different axes. So it's like a gyro, which is normally used in mechanical terms, but here you have the complete tourbillon, rotational as well as a revolution. So it combines both the aspects over here. Usually gyros, one of the most distinct ways that to recognize a gyro would also be the conical hairsprings that they use instead of the flat hairsprings that are used in traditional tourbillons. I especially chose this particular watch because what you have here over here is a gyro tourbillon. You have the day and night indicator, and here what you see is a monopusher chronograph integrated within it. So you have the minutes passing, the hours. So here you have a chronograph which is represented through an analog and a digital medium over here together, which I found quite ingenious actually. I have never seen this in modern watchmaking. Here's another example of a double axis tourbillon again. So you would have you would have two axes, one going this way and one going this way over here. Just added a few more examples. This is done by an independent watchmaker called Thomas Presture. Here you have a principle very similar to the gyro, going on a triple axis. A work by Aaron Beschy, and here you have Vianney Halter, both independent watchmakers. Fairly simple. What the double tourbillon, you have two tourbillons together. A few more examples. Here one might say that, oh, I'm only seeing one tourbillon, but actually Grubel has Grubel Forsey does this watch, and they have inclined this tourbillon, I think at a 20 or a 30 degree angle, and they have two tourbillon systems running simultaneously within one cage. Highly technical. And here you see Grubel's twin tourbillon system. So 2 and 2 together, hence you have a quadruple tourbillon system for an astronomical price.
So quick question before we move on from tourbillon. So very good question from Karishma. Does it make any difference to the watch when you have double, triple or quadruple tourbillons? Like, what is it for? In my question would be why? Like, what is the need of so many things?
Okay, so from a maker's point of view, so I would split it into two, and I'll give you a really honest, unbiased opinion. 2 points. One, from a maker's point of view, pride and joy, innovation of mechanics, because it's not as easy as it sounds. Okay, oh yeah, we just put two tourbillons together and we made 4 of them. No, it's not like that. If you have 4 regulating organs over there, which one is, how are you going to average out the timekeeping aspect of it? What impulse is it going to pick? How is it going to affect the timekeeping? It's a very, very deep study. Manufacture of tourbillons are not easy, but are they essential? Well, honestly speaking, the way science has evolved, technology has evolved, manufacturing techniques have evolved, you don't need to spend over $100,000 to get a tourbillon to get a precise watch, if that's what you're asking me, you know. So from a mechanical innovation point of view, fantastic. From a consumer's point of view, really fascinating, and it really pulls you in when you sort of look at the tourbillon operation. But is it essential for the precise timekeeping? I really don't think so. Just a matter of a second or two there, because a lot many chronometers also function exceptionally well, which are, I don't know, maybe one fourth the price in comparison to what you would pay for the tourbillon. I hope that answers your question.
Yeah.
All right. So we'll move to minute repeaters now. So minute repeaters basically are a miniaturization, more portable aspects from what we normally see in our grandfather clocks, our mantelpiece clocks, carriage clocks, which have a chiming capability and so forth. So it's always very interesting. And to me, from a complication point of view, I find a well-made repeater one of the most hardest complications to make. And to me personally, as a person, I would always be more inclined towards a minute repeater rather than a tourbillon for myself. So normally we don't see a certain amount of repeaters that will be going in the initial bits, but a quarter repeater is the one which would chime the quarters out for you. So it will strike the number of hours and then the number of quarters in a different tone. So you will always have a distinct tone for the hours and a distinct tone for the quarters and the minutes. So if it has to tell you the minutes, it's usually a separate note, a sound quality. But if the quarters have to be sounded, it usually takes it together. So if it's a ting for a minute, so it'll go ting ting for a quarter. So it'll be a quick double for the quarter. So hence you have the quarter repeater over here. You don't see more of it. Again, these watches are way old. They are not absolutely the latest ones, but these are the only examples that I could find apart from pocket watches. So I wanted to show it to you in wrist watches for a quarter repeater. Of course, the half quarter repeater is extremely rare, very, very rare. Okay. It basically can sound you the half of the quarter, that is the 7.5 minute sequence. These you can only now find in museums. Nobody makes them anymore. You have 5-minute repeaters, which you can still find in contemporary watchmaking. Here you have a few examples over here. The 5-minute repeater would sort of first sound off the hours to you, and then instead of sounding minutes to you, it will only sound you the 5-minute intervals. That's how a 5-minute repeater works in comparison to a minute repeater. And of course, a minute repeater will always, here you have a few examples. It would chime you the hours and the minutes in exactly 2 different tones. Decimal repeaters, like say how we have the 5-minute repeaters. So after sounding of the hours, okay, it would give you sequences of tens. That's how a decimal repeater works. So instead of chiming the quarters, okay, followed by the minutes, it will give you the number of 10-minute intervals after the last hour has been sounded off. It's a bit complex. Gets a little time to get used to the system of hearing and understanding time that way, but it's a very innovative mechanism. I think the only examples I could sort of really find from good makers was between Kaributilian and Langazon. And then of course you have the grand sonnerie. So the grand sonnerie would be, whenever a grand sonnerie is in place, there is a grand sonnerie and a petite sonnerie. So let me just explain the difference to you. So the grand sonnerie, when it is active, okay, when you are at a 15-minute interval, it will give you a 15-minute interval without you activating the push piece. Okay. When it goes to the half an hour, it will sound the half an hour. When it's at 45 minutes, it will sound the 45 minutes. And then when it gets to the hours, it will sound the complete hours and then the minutes to you. And that's how it's done. So it's like the chiming clock in your house, which should go like tang, 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 tang. And then it'll give you the complete hours, like 1, 2, 3, 4, 5 to whatever hour is it, and then it'll stop. So that's how a grand sonnerie works. A petite sonnerie will not chime the quarters. It will just chime the hours when it completes an hour. And of course, you also have the minute repeater function. So in between all this, if you need to know, if you want to sound the repeater at that time, you're free to do so, because you can just activate it via the pusher or the lever, which is there to the side of the case. And of course, then you have the Westminster carillon. most of us know of the Tower of London that houses Big Ben, right? So it has a tune. So when it goes to the first quarter, it goes like tung 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 tung, and then when it goes to the half an hour, it will continue with the melody tung 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 tung. 45 minutes it will continue the melody, and then when it sort of reaches the main hour, it will play the whole tune and then sound the hours together. And that's what you have in a Westminster Carillon over here. So Westminster is the tune which the Big Ben sort of chimes, and that's adapted by the watchmaking brands because it's really lovely and soothing to sort of listen to. And in this particular system, this is one of the newer ones which Jije has done as a brand complication this year. The gongs are sort of attached to the crystal itself. So the decimation of the sound quality is much more sharper. The notes are more refined, more crisp than usual minute repeaters. I personally find that steel as a medium, as a metal, is the best conductor for sound when you're doing a repeater. But imagine a brand coming up with a steel minute repeater telling you that, oh, listen, we're doing a minute repeater, here's 300,000 francs worth of a bill, but I'm going to give you in steel. And hence, nobody understands that correlation and saying, oh, steel watch so much, can't believe it. But no, it's the technology that is housed inside, which is more precious than the actual precious metal being used in the watch. But still, a lot of brands do continue. Some do it in titanium because it muffles the sound much better, and you know the output is much better. Of course, gold is still used, platinum is still used, but I find steel as the best possible option to have a minute repeater in. And of course, this was one of the watches invented by Abraham Louis Breguet himself. So just to give you a sense, you see these are the striking hammers of the repeater which strike the gong, and hence you get the tune. Okay, look over here. The hammers are there, but there are no gongs. So this was this particular invention is known as the dumb repeater, because there's no sound, but you get that little if you tap with a spoon on your desk, it gives you that kind of a tonal quality. So while you know, if you wanted to be a discreet gentleman and sort of know the time without offending your host, then probably you could just activate your repeater, feel it in your hands to how many strikes it's giving you, and it would be like, oh yes, of course, I'm enjoying the evening with you, but yes, I know what time it is, and I want to excuse myself out of there. So I guess it sort of comes from that aspect of things. Of course, we don't see the dumb repeaters in modern and contemporary watchmaking anymore. And of course, one of my personal favorites is the way mystery is done. As the name says it all, you do have the complete watchmaking movement over here, but then it's mesmerizing to see how the hands, the hour and the minute hands, are just floating away, you know. So that's the mystery. And if you go back roughly around 150 years, Cartier made these kind of clocks, the mystery clocks. So if you go onto Google and you just Google Cartier mystery clocks, you'll find an array of beautifully crafted ornamental mystery clocks out there for you to view. Unfortunately, those clocks are like really valuable now. They're mainly with private collectors and museums. But if you like something that sort of ticks your fancy with the mystery, then I found two good makers. One is Cartier and one is Konstantin Chaikin, who's a Russian watchmaker. And I think we're coming to the end of our discussion over here. So automata, what automata means is when you have, it's like mechanical puppetry. You know what I mean? It was an expression of art where watchmakers at that particular point of time made these mechanical elements where, for example, over here you see here he's playing a game of dice over here. So when you activate this particular pusher, you push it down, okay, is the time his hands will start moving over here while the minute repeater in the background tells you the time. So it's a beautiful expression of art and mechanics put together in watchmaking. Here we have an erotic scene, something really intimate between a man and a woman. And by the activation of a pusher, you could actually see them making love. So that's where I'll just leave that. Use your imagination. And over here is another table timepiece done by a gentleman called Raoul Pages, independent watchmaker. So his automata is about a tortoise, as you see over here. And apart from telling time, this tortoise also sort of walks all over your table or whichever surface you sort of put him on. So I think automatas are also a complication which is extremely technical, needs a sound knowledge between the artistic crafts, because I'm sure if you didn't have the artistic sense and the creativity and the know-how to sort of, you know, enamel this out, micro paint this out, you know, make these little pieces out of gold, the mechanics behind this would not support the aesthetics and vice versa. So I think it's a good amalgamation of arts and the craft of watchmaking coming together into an automata. So I guess, yeah, that's enough of rambling for me for now. And I would just say thank you to BWE and all the moderator Puneet for giving me the chance and having the pleasure of your company for this evening.
Thank you so much, Sarosh. Quickly, any questions? We can just open our mics up, and in case of questions, please shoot directly to Sarosh. You don't need to put a chat or anything.
I have a question.
Yes.
So we're talking about complications, and yes, of course, we obviously couldn't go through all of them like moon phases and stuff, but there is a brand that calls themselves the master of complications.
Frank Muller, are you talking about Frank Muller?
Yeah, so they do things like the crazy hour, they do things like the secret hour. What are your views on
The
that?
master banker is an ingenious system, Karishma. I don't think anybody has 3 time zones, all configurable to the half an hour, which is very essential for countries like ours, and only via a single crown. It's amazing.
Yeah.
Amazing. Yeah.
But like as a brand, they have completely destroyed their reputation. But I still feel like it's a very underrated brand when it comes to complications, because I do feel like they do some fantastic work.
Well, yes, of course. As you mentioned, you know, the crazy hours, I don't think anybody else does it. I think it's a patented system by them. The master banker system is also patented by them. So they've had I think late 90s was the best run I think Frank Muller ever had. You know, early 2000 and the late 90s is the best run that Frank Muller has ever had.
Yeah, I just thought I should bring it up since we're discussing.
Thank you for sharing that. Thank you.
Anyone else? Cool. I think we are already over time, and Raksha Bandhan season with COVID. A lot of other Zoom calls might be scheduled for a lot of people. So thank you so much, Sarosh, for this amazing session. In fact, I was just thinking, and a couple of messages I got from my team members was, you know what, we should kind of tell him to do this and burst the whole presentation up, and we should go into detail of each complication per se. I mean, it was very interesting to know a lot of things. Interest of time, we could not go into much detail. I know that from inside you were dying, because I remember talking to you about this a lot, and the amount of knowledge this man has. The complications is really high, and whatever we saw right now I would call it a small trailer of what. And I think it'll be best if we can meet you later after COVID things settle down. We can do something like a physical get together wherein you can impart us some knowledge.
Because I look forward to. Thank you very much.
So guys, everyone else, please, thank you so much for making it tonight. I know it's a Sunday evening with Raksha Bandhan on the head, but great you guys came in, joined. Thank you for being a good sport. And I hope we have another session very soon. And we are planning to do a series of these sessions so that we can get some knowledge out of these watch experts. And yeah, so looking forward for the next ones. Please stay tuned on our social media handles for more details. And in case you want to service any watch, the man on the screen is the person you need to go to.
Thank you very much again. I wish you all a lovely evening ahead and see you then. Bye-bye.
Thank you.
Thank you, Sarosh. Thank you for the talk, and thank you, Puneet, for organizing the whole thing.
Good.
Very interesting.
I think I'm connected with you on Facebook, so why don't you drop me a number? We can always have a chat. Rajan bhai, so good to see you. Thank you for joining us.
Thank you. Always.
I'll do that, Sarosh.
All right.
I'll send you my number.
Nidhi, thank you.
Thank you, Sarosh, for doing this. And Puneet, thank you so much.
Thank you for joining, sir.
Thank you. Thank you.
All right. Cheers, guys.
Cheers.
Bye, Puneet. Thank you.